All right, our friends, we are back with another
fusional episode.
Episode.
Yes, sir.
Of V8 Radio. I'm Kevin Ostie, joined as always by our esteemed, with a strong vocabulary, Mike Huball Clark.
Right.
A fusioned episode.
A fusional episode.
Fusional.
And I say that, Kevin, because I recently acquired a new life skill. And in no small part thanks to you. And that life skill, my friend, is you are now looking at, and friends, you are now listening to a man who knows how to weld.
Yay, right on.
I can take two pieces of metal and I can fuse them together to become one.
Well, interestingly, as we talk, I become confused as well.
Yeah,
you confuse metal, and you confuse me.
Yes.
That's outstanding, man.
Right on.
I dig that. That was good. Mm-hmm. Fusional.
Thank you. Fusional.
Yeah. Well, that's obviously...
Not delusional,
no.
Fusional.
Right. Well, it's obviously going to be a big topic here today then.
Absolutely.
But before we get into that, now that everybody's all excited... typically on this show, we start off with an automotive trivia question of sorts, which is different from an automotive trivia question of shorts.
Yes.
Did you have time to prepare a trivia question?
Certainly I did, sir. And have you had time to prepare one?
I have. I'm actually going to consult my notes. So why don't you go first? I'm listening.
Dig it. Will do. All right, Kev. Now, you have coming up the V8 TV drive-in coming up this August.
Oh, yes, the drive-in cruise.
The drive-in cruise. When and where was the very first drive-in theater opened?
Holy smokes. Ah, man. Now
a man
is a question.
Who was running a drive-in cruise-in should know these things.
Well, here's the ironic part is I did know this. Because a couple of years ago when we started our drive-in cruise event, I did some research, and I was learning all about drive-ins and how many there are left and when did they start and blah, 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 blah. Unfortunately, my mind is like a sieve, and sometimes I get confusional, and I lose things. So I know, for example, the Skyview Drive-In in Belleville, Illinois, where we host our event, launched in 1949, and I know that was definitely not the first. So if I remember correctly, which I'm not saying by any stretch that I do, it was in the 1920s, 27, my guess, 1927.
1927, the man says.
Yeah. I'm going to say that's the first drive-in movie theater opened in 27.
All right. Okay. The other part of that question was where?
Yeah. Right. See, I already forgot that there was a second part of the question. It was in. So now, if I remember correctly, which I clearly don't.
We know it wasn't Belleville, Illinois.
No, it was not. I do seem to recall being somewhat surprised by the original location, thinking that's not where I would have thought. But I forgot where I put that. So I'm going to, just for fun, I'm going to say it was in Kansas City.
Kansas City. All right, 1927.
Right.
Kansas City. Kansas City, Kansas? Or Kansas City, Missouri, my friend?
Yeah, probably, let's say Kansas.
Kansas City, KC, Kansas.
There you go.
All right.
Brutal.
Well, these things have to be done.
They do. I'm already fueled with disappointment. Because I did know this. I checked it out. But apparently there were more pressing things that needed to occupy my feeble noodle on that day. And it was released back into the wild.
Okay, back into the universe.
Yeah. All right, well, on that note, I have a question for you, my friend.
Lay it on me.
You're familiar with the Chrysler 426 cubic inch Hemi engine?
Indeed.
Did you ever think about why the 426 was 426 cubic inches? And that is the question. Why?
Well, not until this second I thought of that, Kevin. Oh, wow.
Yeah. The answer was revealed in a drive-in in Kansas once.
Was it? During a newsreel.
Yeah, in the 20s.
The 426 Hemi was the 426 due to NASCAR rules that limited displacement to 427 cubic inches. The time that the Hemi came out.
Huh. So it's got nothing to do with the fact that there might have been... I mean, there's several things to consider when you lay out an answer like that. For example, there was a 426 wedge motor prior to that. And there was also the 440. So why didn't the Hemi grow to 440? You'd think they're trying to make power. These are things that I would consider.
I understand.
If asked myself.
I see where you're coming from on this. However, I think it had more to do with racing, and the racing rules said NASCAR says if you run a stock car, you have to offer so many to the general public. And the Hemi was first the race Hemi, but then was somewhat detuned to become the street Hemi.
Correct.
And I believe that they carried over the 426 cubic inch size for that reason.
Well, that is a very plausible answer.
Thank you. I like to applause around a little bit.
It's applause that refreshes.
Yes. Let's give us a round of applause, people.
Oh, man.
Hey-o.
Okay, well, I will note that. It was because of NASCAR regulations.
Yes.
All right, right on. Did you know the biggest thing that detuned the race Hemi to the street Hemi? You know what they did to do that? It's right up your alley.
The heads?
Well, they reduced compression. That was a big one.
Right.
The race Hemi was like 13-1, and the street Hemi had to exist under the hood of a Cuda that was being sold on the street. So it got dropped down far. And then, of course, they did hydraulic valve lifters.
Hydraulic valve lifters, yes. That's right. The race Hemi was a solid lifter engine.
It was. And, for a guy who's got valve train on the brain right now.
Yes, I do. Indeed.
So,
boy, howdy.
Recapping our recent experience, you came down to our shop last weekend to visit, and
yes.
We ended up with an extra set of cylinder heads, those Pontiac 6X heads from a late 70s car that we thought might work on your GTO engine to reduce the compression. How's that story going?
Correct. That story is, it's moving along. I was actually at my buddy Randy's house. Randy. And
that's next week's trivia question.
Yeah.
For the loyal listeners.
Oh, perfect. But excuse me, I was at Randy's and we tore the heads down and we looked at them a little bit, and they're going to need some attention. They're going to need valve guides, and they're going to need some valves. Some of the valve stem tips are kind of chunked a little bit due to what, I have no idea. But I also noticed that on the rocker arm fulcrum had some of them had a little bit of a shim on top where the nut tightens down on top of it to probably offer a little bit of adjustment to probably take up a little bit of slack due to possibly cam wearing down or maybe the valve wearing down or what have you. So,
well, I believe that was a 1977 or 78 engine, 77?
Yeah, I think it's a 77, yeah.
So who knows what repair was done to it along the way to
Exactly. Yeah.
To bring it back. And of course, that particular engine, the bottom end was grenaded. There was giant holes in the block and the pan, and rods came apart and everything. So it doesn't surprise me that, I'm still a little curious about those little chips out of the valve tips.
Yeah, I've never seen that before.
Maybe, that would suggest that they were too hard. Maybe it got hot at some point. I don't know.
Maybe, yeah. I mean, it was that oil that was in there was pretty stinky. It smelled pretty burned.
Yes, well, so, the failure at the end was pretty catastrophic. So
yeah, right. Well, what I found was interesting was when we pulled the one side off, one of the pistons was rotated 90 degrees,
right,
in the bore. So that was you could tell which one was the bad one.
Had a little rod twist going on there.
Yes, just a little tweak, a slight adjustment.
So, I mean, I honestly probably would have expected at least a valve job or lapping anyway.
Mm-hmm. Right.
Are you going to do that trick with the big block Chevy style studs to give yourself some adjustability?
Totally. Absolutely. I am. Yeah, to me, that's a no-brainer. I mean, because those Pontiac ones, they're the bottleneck studs. They're 3/8, and you tighten the nut down at 20 foot-pounds, and there's no adjustment on there. So if any slack develops in there, you're going to have a valve train noise that can't be adjusted out. Mm-hmm. So that should have been like that from the factory, in my opinion. But
I agree. It's a lack of adjustability. I don't know if it makes for more dealer money to be tuning those things up or whatnot.
Maybe.
But who knows? Yeah. All right. Well, at least you got some cylinder heads now, though, and
they should. Thank you. I appreciate it.
Oh, you're welcome. Yeah, and that should bring the compression ratio down enough to where your new bottom end should be 9.1,
9.2.
9.2. It's going to be right on. You'll be able to run any gas you want.
Exactly. So that'll be nice. So that'll help me with cam choice and maybe give me some leeway as to what cam I use. I have an idea of what I want, but I'm all but finalized on that decision. So it's just a matter of getting everything and all that good stuff.
Kind of like how I was on the trivia question a few minutes ago.
Kinda, yes.
All but finalized. So the rest of your visit, you and our buddy Paul came down.
Yes.
And got to spend a little time in the shop.
Yes, we did. It was terrific. That was a great time. I could spend all day there, and we almost did.
Yeah, we did. We spent probably 6 hours there.
Yeah. We put almost a whole shift in there.
Yeah.
I'm waiting for my paycheck.
Yes. Well, the cool thing was I remember, we talked in the past and on this show and about the fact that you never really had the opportunity to learn how to weld. And in our V8 Speed and Resto shop, we certainly have a lot of welders. We do a lot of welding. We're welding every day. And I thought it'd be fun if you guys came down to pick up those heads. Let's take a few minutes and learn to MIG weld, which turned into 6 hours. But
yeah, right.
I mean, I honestly think that style of demonstration, the actual learn to weld part is pretty quick. But we took some time to do a little metal finishing as well.
Right. Yeah, and you taught us how to set up the welder and how to not blow through your metal based on the thickness and the gauge of what you're welding on and all that stuff. And you're a really good and patient teacher for a couple of knuckleheads.
Well, I appreciate that. I was thoroughly impressed with your work.
Thank you.
Yeah.
You are the Mr. Cotter to Paul's Vinnie Barbarino and to my Horseshack.
It reminds me of, Juan Epstein, one of his famous quotes, when the Sweat Hogs were going to play poker in class, of course, and
well, of course.
And well, actually, it was Freddie Boom Boom Washington who had the quote, and he said, "Because Mr. Cotter won't let us play with actual money, 2 blues and 2 whites is worth 2 blues and 2 whites."
Oh, that's perfect.
So, well, the whole deal about MIG welding is that it's one of those skills where if it's properly taught, it can be rewarding and you can be successful pretty quickly.
Sure.
You need to know a few basics. And the far vast majority of people that MIG weld in this world are self-taught. And
is that right?
I believe it, because you can go down to your local home improvement store or jump online, and for a couple $100, you can get a wire feed metal inert gas welder like a MIG welder, but one that uses a flux core wire instead of a tank, and those are the cheap ones.
Sure.
And I think a lot of people kind of, I'm going to say they fall for that because a wire feed with a flux core wire is a very challenging weld. You don't have the control that you do with a gas MIG welder.
Sure.
So I think we see a lot of people that get a cheap welder, and then they try a few things, and either they get frustrated right away because they don't have somebody to help them out, or they can't overcome the challenges of that particular tool. Because a lot of people don't want to spend a little more money to get a decent, reliable, controllable welder right away if they don't know they're going to do it, or they're only going to do it for one job or something.
That's a good point.
So I've also seen time and time and time again, and I credit that trick, and I'll kind of describe it. The method that we use to set up the MIG welder came straight from Jeff Noland. And Jeff Noland is the guy that runs HTP Welders, HTP USA.
Oh, yeah?
Yeah. And
that's
where we get all of our welders from. The wire feed MIG and the TIG welders all come from HTP, and we've got a couple of resistance spot welders as well. And the deal there is that Jeff is not only a business owner, but he's also got an engineering background. He's got a metal background, so he knows how to do this stuff.
Right.
And Kelly and I went to the HTP facility. It's just outside of Chicago. And
really?
Yeah, it's in Arlington Heights. And he does classes there. Yeah, you could go there. You and Paul could do phase 2 over there if you wanted to.
Right on.
Yeah. And the thing that he showed us, first we learned about, what is MIG welding, and it's an electric arc weld that is shielded by a gas. And the reason why you pump the gas around the arc is because the atmosphere of oxygen that is, in our normal atmosphere makes that arc burn hotter, and you lose control. So by pumping in a gas that is inert, that doesn't burn, you can kind of slow down that arc and control it better, and deliver only the amount of heat you need in that arc to fuse your metal together, melt the puddle. And then the wire is fed in as kind of like, the opposite of a wick. It's basically feeding the fire and making the electrical connection. And it's a dance of timing, because as you pull the trigger, the gun starts, or the machine starts feeding out the wire. And when that wire makes contact with the work, which is grounded by the ground cable, it arcs, boom, and it's done. And the trick is to feed enough wire in so that arc becomes continuous and not too fast to where it can't consume it fast enough and it burns and everything else.
Pops and all that.
So, they always tell you go for that sizzling bacon sound, and there's a few things to do. You have to set the voltage rating on the welder so that the heat of that arc is the correct level of heat, so that you have the right amount of penetration into the steel. And then you got to set the wire speed so that it matches. And the one trick that Jeff taught us is that rather than, some people like to look at a book or a chart, and they'll say, okay, I've got 18 thousandths thick mild steel, and then I look over in this column, and that means for 23 thousandths wire and this gas and this welder, I need to crank this knob to this position, and then it all lines up, and then I'm welding. And that definitely has merit, but what we've learned is that every piece of steel is different. It might have a coating of oil on it. It might be laying on a table that's acting like a heat sink, which is kind of how we did it for you and Paul.
Right.
Or it could be in free air, like on a vertical part of a quarter panel or whatever. So there's variables, ambient temperature. I'm sure there's other environmental things that play into it. So rather than just go by that prescribed number, what Jeff taught us to do is pull the trigger and let the welder weld on a equivalent piece of material. And then adjust your wire speed while the welder is feeding wire and dial in that sound.
Right. Yeah, and that's, by God, that's exactly what we did.
And it seems to work.
Yeah.
So
I think it worked great.
It did work well. And then, of course, you got to go back and look and see if your weld bead is piled up on top of the steel, or if it's melted into the steel, or if it's all the way through it.
You're right.
And you have a big hole.
Yeah.
That's the heat setting then, or the voltage will allow you to, if you tune the voltage, you can get that middle ground of your penetration. So why don't you tell us what it was you did?
What we welded?
Yeah.
Oh,
and you know, you've graciously said you had a good experience with it, but I mean, I normally don't get feedback from this outside of, hey, thanks, and they go, weld. So did all that make sense when we were going through it, or, you know, what do you think?
Oh, it totally made sense. I mean, I understand that the higher voltage, it's going to be a hotter spark. It's going to penetrate more. The wire feed is going to have a big effect on the quality of the weld that you have. And it's, you know, what you said before, the having a chart and seeing all the variables and how to dial it in does have merit. But there's nothing like being there, dialing it in by hearing what it sounds like, listening for that sizzling bacon sound. And having you teach us that really went a long way. And that way you actually you can tell someone till you're blue in the face, but until you actually do it, it's totally different.
Yeah. Well, and I think people get frustrated because if they do it kind of the traditional way, they'll pull the trigger, make a little bead, say, well, that was too cold or too hot or didn't sound right. Let go of the trigger, go back to the welder, turn a dial, and then go back and forth. And there's no cause-effect immediate relationship.
Right. Yeah. Because I noticed when I was looking away and just listening and turning that wire speed, you could definitely hear the difference. Mm-hmm. You could hear it popping when it was too slow, and you could hear the difference when it was too fast, and then you could see what you had when you got it dialed in just right, when that sound was just perfect, and then you did a practice run and it was really nice and smooth.
Yeah, it works well. Mm-hmm. So we try to tell people that it's very similar to setting the timing on a car. You know, because you have a sticker on the core support that says this engine needs to be set at, 6 degrees before top dead center. And many people would go ahead and set that, which might have been fine the day it was new on a different fuel with different plugs and all the rest. But until you move that distributor around and find the sweet spot, with a vacuum gauge or whatever, that's the exact same thing that we were doing with the welder.
Totally, absolutely.
So we took a couple pieces of, I believe, 18 gauge and cut them in half. And I said, here you go, put it back together.
Right. And by golly, we did.
Well, yeah. And what was cool is that you didn't just stick it back together. I mean, again, using the technique that we've all seen in the magazines on the shows, doing the tack weld technique instead of burning a whole bead across. Now, tell me how frustrating is that? Because really all you want to do is pull the trigger and go.
Yeah, exactly. You do. I mean, you got to do a little zzz, and then go to the other side, a little zzz, and then you got to keep filling that in, and you're like, did I fill? Is that all the way? And you look underneath, oh my God, I got more to do, and you got to keep doing it. It's hard to appreciate how much time you is required to, like, say you put a nice whole quarter panel in. Holy cow. That's a lot of real estate to cover.
Yeah.
That's a lot of time.
Well, I mean, and that's a great point. And the reason why we do that one tack and then go to the other side of the panel and do another tack is purely to keep excess heat out of the work. Your job was on probably a 3/8 thick steel table, and the shop temperature was probably 55 degrees in there. So that table was cool, and it was acting like a heat sink to keep your test work from warping. When you're doing this, like you're saying, on a body panel that might be 18 or 20 or 22 gauge, and it's in free air. It doesn't have a big giant metal heat sink backed up against it.
Right.
And you start welding, you can blow through it real fast, but also you can warp it. And by warping it, you've just introduced all kinds of time into fixing it. And this is where these projects go off the rails because, if you take a bunch of time and cut the panels and make them fit properly, and that's another thing is there are some people who believe in putting a pretty decent sized gap between panels that are being MIG welded. And my own experience is you want to tighten that gap up because what I've learned is that you can make something out of nothing with a MIG welder. You can, as long as you can strike an arc on something, you can draw a circle and pull the trigger and build it up and build it up. Effectively like making a steel ice cream cone. You can you could soft serve yourself a big thing.
Right.
But it's going to be hotter than the sun. And what I notice is that people that put a gap between their panels, they'll do a few tack welds to hold them in place, but then they're also relying on the wire from the MIG welder to add material to bridge that gap. And by doing that, it's got to be hot. So it's getting hotter and hotter and hotter, which will make the, you ever see that commercial for the dishwashing detergent where you got the grease in the sink and they drop the drop of soap in, it all runs away from the drop?
Right.
That's what the panel does from too hot of a weld.
Oh, really?
It just burns back.
Oh, wow.
And you go, oh, man, I wanted a tack weld, and now I have a half-inch hole.
Yeah, there's more time.
There's more time. So how do you fix it? Well, some people say, well, if I do a few zaps on that hole, eventually I can build that up with weld.
Build it back up.
Right?
Okay.
And now I've closed up my hole. But you're running the risk of turning that half-inch hole into a 2-inch hole.
Yeah.
And
plus, all that welding, you're introducing a heck of a lot of heat in that panel still, so you're risking warping it even more.
Right. So at that point, you're forced with, well, I'm going to make a patch. So I'm going to make another little square of steel to go in that hole. So you've got time cutting that and fitting it and everything else. And then your patch area now has a frame perimeter of tack welds around it. In the middle of this panel, it maybe is supposed to be flat or have a curve, so it doesn't match. And it just goes down the line and off the rails farther and farther until you flip the lights off and you walk out of the garage and you don't look at the car for 6 months.
That doesn't happen.
Yeah. So what we've learned is by running that gap tighter and being very disciplined about one tack weld and then move to the other part and another tack weld and then come back. And, there are those who actually use a compressed blowgun on the compressor to cool the weld to kind of speed the process up.
Sure.
That gets a little dicey. Some say that you're not really supposed to, quench that weld and cool it quickly because it can become brittle.
Okay.
But to use this example again, the grand scheme of this job that we're describing of putting a patch panel on using a MIG weld technique all the way through it, we tend in our shop to not do that at all, primarily because it's high risk, it's a lot of time, and when you're done, as you learned in your lesson, you're done. You've got a line of closely placed tack welds the whole length of your work area, and now you have to dress those welds.
Yep.
So you got to grind them. And in your case, we started with a little 3M roll-lock abrasive disc, and I think we started with about I don't know if it was a 36 or a 50 grit. It wasn't super harsh, and it was half worn out anyway. It was just one that I grabbed laying around.
Right.
But tell me about that experience of grinding those welds down.
That it took some time, and you have to have a touch to do it. I mean, it can get away from you if you're not careful. So that's really what I learned about that. And you gotta practice, and you gotta stay focused on the work, and know where you're grinding, and try not to grind onto the good metal and cause it to, God forbid, cut a slit in it just from grinding it through or whatever.
Right.
But it it requires some skill.
And
it's not just throwing the grinding wheel over it and getting it smooth. It takes skill, it takes time.
What I noticed as a tip that I think I pointed out to you while you're doing it is it's our nature to want to be aggressive and get it ground. Let's get this done.
Yeah.
So what people tend to do is angle the grinding disc.
Yep.
And use the edge because it's the one it's the part you can see.
Right.
And initially it has more effect faster.
I think it also gives the illusion of having more control because you're at a smaller area, and then you can control where that wheel is hitting a lot better than when you're laying it flat.
Yeah, right. And so what I told you that day is that we used to see people using that edge in the very beginning of the weld. They benefit from everything you just said, but then that ring wears down on the disc, and you don't have the level of control that you think. So it's a more efficient and better way to grind if you kind of mow the whole thing down by putting the disc just about flat over the work, and then you're using the surface at the very center of the disc all the way out to the edge,
right?
And moving it back and forth and keeping it moving. Because imagine if you had the patience to do a giant MIG weld and it was still straight, and then you go back and grind it and put too much heat in it and warp it from the grinder.
Yeah,
because you can do that too.
Yeah,
and that's no fun.
Another idea, another thought too is, those when you wear out the edge of that disc and then you toss it. Well, that's a lot of material that goes unused on those discs, and those discs aren't free.
No,
and that adds up.
Yes, yeah. You've used 98 cents out of a $7 disc.
Right. And you threw $6.602 away.
Right.
And now that adds up. Say what would normally use maybe on a full quarter panel, maybe 3 of those discs. Well, you use 7 or 8, and that costs too.
Yeah,
that's material cost.
It's far more than 3 on a quarter panel, no matter what.
Well, you know what I'm saying.
Yeah, well, I mean, and there's a sidebar there. We use those 3M discs, and they're not cheap, but they do last the longest of the ones that we've tried. And you can go places and get the 89-cent discs, but they're done far sooner. So sometimes the abrasive wears out and comes off and everything else. So now you've got 3 operations that are risky. 1, cutting the panel to fit right. 2, welding it. 3, grinding it. And then there's several levels of grinding. You did a rough cut, and then we changed the grit to, I think, a 180 and did more of a finer polish on it. So that's why we always try to replace a quarter panel at all the factory attachment points, which doesn't require a MIG welded bead like that. It's a plug weld, which is having something with a hole in it and filling that hole with weld instead of trying to do a big long seam. And you'll get that panel on with, 150th of the number of welds, and it's as strong as the factory designed it.
Sure.
And I cringe, man. I see people that have a car that's popular where you can get a full quarter panel to the roof. We got a Mustang in the shop right now, a 67. You can get every part of a 67 Mustang. And some poor guy bought an entire quarter panel and cut it right through the middle and welded it on using this tack weld procedure. And it's a correct procedure, but man, if you just would have went to the sail panel and drilled it out like it was supposed to be,
right,
you could have had that thing done.
Just put the whole thing on.
Right, perfect, done.
Right, it would be seamless.
Exactly, literally seamless, and
literally seamless.
Yeah, and not all warped from grinding and welding and blowing holes in it and everything. So,
right,
I think there's an attraction to putting things together on a butt weld type fashion, because it's magical when you can get them together and there's no evidence of the split, right?
Right.
So
sure.
I thought your panel and Paul's panel looked really, really good, because when you were done, you had no idea that was ever 2 pieces.
Nope, sure didn't.
Until
flip it over, you sure did. But
but
on the good side, it looked like one piece of metal.
Right.
It was really trippy.
It is. It's cool. And to be able to say, I did that,
Exactly. I was telling everybody who would listen, honest to God, I was like a kid. Look what I did. Woohoo!
Well, it's still in your pocket, isn't it?
Yeah, I'd probably, God damn it.
Well, and that's cool. And I think we like to be able to do that and get that super high level of satisfaction to say, this is what I did. And we certainly do a lot of butt welding and finish grinding. And in fact, when we do a patch panel on a car or something, we'll actually do both sides. We'll grind the other side and dress it as well, so that
right on.
From either side you can't tell anything ever happened. And
That's cool.
And we might use a TIG welder instead because it's a different heat characteristic and a slightly it's less additive, meaning it's not constantly feeding that wire in there, so you can just use heat to melt the two existing pieces together, and then that becomes a naturally slightly thinner joint and less heat affected area and less cleanup.
Okay.
But if we can avoid it, we would rather do the entire panel. And people say, well, it's $89 for a patch panel that goes over the wheel lip of my my Camaro, or it's $400 for the whole quarter. But if they go through it, that $400 is worth it.
Yeah. I believe it. I mean, but if a shop is doing it too, I mean, you're going to probably save a lot of labor putting the whole quarter in versus like a whole lower quarter just in welding time alone.
Correct.
And dress up time and all that. So, it's give and take, but, my personal preference, I'd rather have one solid, good piece.
Yeah, and it's less risk, of course.
Totally.
I think also when you do an individual, and we've done them, like I said, both ways a million different times, and we try to assess if this car, we try to keep as much of the original steel there as possible. Just to keep that, that soul of the car here.
Right.
But, you got to consider the budget and all that extra grind time and weld time and fitting time and cutting time. And then when you're done, well, that was just one piece. Maybe you got 3 more to do on that same panel.
Ugh.
So, what's the best way to do it? But
right. Every car is probably different. I mean, if it was like, the super valuable one of one car that you'd want to keep as much sheet metal as possible on, original sheet metal, you'd probably go the patch route and just suck it up doing the kind of time and that extra work that
or you would find,
just to say,
try and find an NOS panel.
That too.
An original repair panel, or you would get a real solid cutoff of another car. And that's sometimes a really good way to go because a reputable yard will cut a panel off 6 inches away from the original seams. So when you get it, you can drill out the original seam area, make it nice and clean, and do it that way.
That's cool.
Yeah.
Right.
Yeah,
cool.
It is pretty cool. But to me, the ability to fuse metal together really changed my life because we've only been talking about it in the body shop type sense. But now you look around and you look at weld beads and stuff, and now you get a little bit of a sense on how they did that. Like on a roll cage, or you were looking at some of the jig fixtures in our shop, and it's like, oh, now I understand, what it might take to have that steady hand and to be able to see what you're working on is hard. Even if you've got a good auto darkening welding helmet, it takes good vision.
Even just on that small little piece I was doing, I found myself flipping up the helmet just to make sure I could see what I'm doing, and then you flip it back down, and okay, here we go.
Yep.
And I like that auto darkening helmet too. That was that was pretty slick.
Yeah, that's definitely the way to go.
Being able to see with that arc going, I didn't know what to expect, what kind of vision I would have through it, but it was neat. You could actually see the weld laying down, and it wasn't too bright, it wasn't too dark. You could see what you're doing, and by golly, I could see right when I blew through that metal the one time too. That first weld, I'm like, holy cow, I blew right through that.
Yeah, look what I'm doing.
Yeah, look at me, Ma.
Yeah. Well, and of everything, I think we spent the least amount of time dialing in those helmets. because we tend to just say, well, this is set for somebody and it's safe. But, in your own welding adventure, I think it's important to spend some time, and because most of them have variable shades and a variable sensitivity. So it might take, more of an arc to darken.
To hit it. I got you.
And the reason why they do that is generally to make them able to be used in bright sunlight.
Okay.
Because if you're welding outside, you don't want your lens darkening from the sun. So they reduce the sensitivity, so you can see it. And then, of course, the fumes that are let off by MIG welding, you don't really want to consume. So that's why I use a full face helmet to kind of let that smoke go around.
Sure.
But yeah, now you can do anything. You can make anything.
That's right, man. I'm going to start a roll cage tomorrow.
Yeah, right. Well, and so what I like to tell people that are new to this is try it, get a little bit of a handle on it, and then now go check out YouTube and go look at other people's cars and see what some of the real hot shots are doing, and see, you'll see right away if somebody maybe didn't know what they were doing. Or don't have a whole lot of experience on it.
Sure. Yeah.
And we were just talking about this in the shop yesterday, as a matter of fact, with John Moss, who's our fabricator. That's
resident genius.
Well, we have a lot of resident geniuses. That's a good thing. Everybody has so much to offer in the shop. It really blows my mind. John's up to his eyeballs in this Mustang project, though, right now. But anyhow, he and I were talking yesterday, and he is always checking out other people's work and trying to learn tips and tricks, because you can never stop learning this stuff no matter how good you are. And he's been trained by, his background's extensive in racing and training and everything else. But what we're noticing is that, so the piece that you and Paul made was essentially, I don't know, all said and done, 3 or 4 inches long, about 1.5 inches wide, with a split right down the middle. So it was containable, and doable. And we're seeing a lot of Instagram heroes, people that are posting welds and little fabrication things online. And you can really separate those who can do it versus those who really can do it. Because, as we demonstrated, your very first time with a welder, you made an undetectable repair. Are you going to be able to do that kind of work underneath a dashboard, upside down, in a rusty car, making something that never existed before? That's the next level of...
Let me answer that question, Kevin. No.
I'm sure someday you could, but
maybe.
But it's interesting to me, and we call them, basically welding selfies, where you always see the people with the selfie where they're in the exact light with the right facial expression and the camera's held in that certain spot, to get that perfect picture of them. But the rest of the time they look like, Oscar the Grouch. So a lot of times you see people online that post this beautiful MIG weld or, this TIG weld with a rainbow colored stack of dimes and everything else.
Yeah.
And the interesting thing is, because this equipment is becoming cheaper and cheaper, more people have access to it, which is fantastic.
Yeah.
But it also means that maybe people that don't necessarily have the full skill set are able to make a few things in their garage and think they're fully qualified to build cars,
Right.
And I only say that because I'm in no way discouraging people from trying it, doing it, and learning it. But we see a lot of things that come into our shop where the customer is like, I don't know what somebody did on this car, but it ain't right, So, like Michael Jordan said, it all comes down to the fundamentals. If you can practice and get that concept down first, and then the technique follows, and then you can apply it to other challenges, other shapes, other situations, that's how you get good, as opposed to just saying, well, on my bench with this giant heat sink table and this, piece, and, I was able to make this perfect weld, I'm going to build your roll cage. And when you said I'm going to build a roll cage, that's what tipped me off, because there are very strict, NHRA and SEC requirements around roll cages, and a proper cage has to get certified and sonic checked and measured for thickness and stuff. And if you ever see grinding on a roll cage, it's not going to pass.
Oh boy,
because,
really?
Oh yeah, because you can't. What's in there? You can't hide.
Oh
it.
yeah, the welds have to be all raw, right? They all have to be
visible,
untouched.
Yeah, you'll never see body filler or custom paint or anything. Generally, it's gray or it's bare. Bare steel's the best. That's the easiest way to get past is with bare steel, so that the inspector can see it all. So they're looking for porosity, and the porosity comes in, as we were talking about before.
Sure.
In our natural ambient atmosphere, there's so much oxygen and fast-burning accelerants that weld arc actually, what I like to say, it's like boiling the metal, and then it cools instantly, but there's still bubbles trapped in it. So if you cut it in half, it looks like a, what was the candy bar?
Like Swiss cheese.
Yeah, like Swiss cheese. There used to be a chocolate bar. You crack it in half and it's full of bubbles.
Oh, yeah. I know what you're talking about.
What the heck was that? But you don't want your weld looking like that, because imagine for every bubble, that's taking away the surface area of the weld and the strength of that weld.
Right.
And the proper shielding gas is what makes that a solid bead instead of this thing full of holes. And that comes from understanding the concept and having decent equipment and knowing how to do it. And, you see on Craigslist, people are selling cars, and it's, there's almost, we're almost envisioning the same thing, a Fox body Mustang, with big tires on the back and no engine, and the fenders are 3 different colors, and it's a race car, and it's got a 4-point cage welded, and it's all spray painted black with grinder marks all over it. Yeah, don't race that car.
maybe a naturally aspirated 4-cylinder engine you could put in there and race it.
Well,
a nice 17-second car.
I can't tell you how many hundreds of these things I've seen because somebody just gave it a whirl. Sure, I can do that, And again, I want to encourage that, and that's great. But when it comes to safety, it's not so cool. So the tip there is, if you're gonna when you go to buy your race car, or or go to have that cage put in your GTO, it'll get certified, and there'll be a sticker or a stamp on it with a date and a certification. And that's how you know that it passed, and then it's safe to trust your life with it, 150 miles an hour.
150, that'd be nice.
Get your brick GTO doing 150? Yeah.
That's right. Wouldn't that be sweet?
Yeah. Now, on the flip side, this weekend I plan on making myself a shelf for my garage for an old piece of stereo equipment that I'm going to hang on the wall.
Right on.
And it doesn't need to be certified, by the NHRA, but it will not be porous, and I will not burn through, and it ain't going to drop my piece of vintage gear.
No,
that would suck.
That has to be protected.
That's right.
There are some things that are just too important to trust to bad welding.
Yes. Yourself and your family are high on that list, but vintage gear.
Yes, for sure. Yeah. But hey, vintage stereo equipment doesn't come around all the time.
Right. Well, you got to make the garage a nice place to be.
You do. You totally do. I need to do that to my garage sorely. That whole place needs to be revamped. So that's one of the things that's been kicking around in my head for a while. So.
Yeah. Well, it's always good to have additional projects on the horizon.
Yeah, I figure by the time I'm 65, I might be able to get around to it.
Yeah. Well, and it's kind of a catch-22 thing in a way, because it's like, I really want to go in my garage, so to have one is great to start with, and I'm thankful for that.
Yeah, right.
And then it's, well, I got to get some tools to work on the car, so then you got to get the tools. Well, you know what, I need a bench, so then you got the bench, and then it's like, well, maybe I need some tunes, so then you work on that. You still haven't touched the car yet.
Right. Oh, boy.
And then I need a fridge, and then, of course, I got my poster, and,
Yeah. You got to build the foundation, man. Yeah. The foundation comes first.
Yeah, next thing you know, on your 81st birthday, it's like, okay, we're set. Now I can start to work on the car.
Exactly.
Although there are many people who, my hat's off to these guys who are on a dirt floor with a basic set of hand tools, and they're building stuff that you'd never even imagine. Just tremendous quality.
Well, even in my younger days when I was, living on my own, when I first moved out here, living in an apartment, and didn't have a garage, and I had to work on my car. I had to drag everything out there to the parking lot and work on it, and hope it didn't rain, and hope it didn't get too cold, and you gotta do what you can with what you got.
That's it.
So yeah, I am I thank my lucky stars every day that I have a garage that I can do this stuff in. It's huge.
Yeah. Your garage isn't necessarily huge, but the concept is.
Right, exactly. The garage, yeah.
Yeah.
So, exactly. The concept is great.
Yes. Well, our time is flying. I do want to throw a little shout out. Yeah. We had a couple of very positive reviews on iTunes about this little show.
We did indeed.
Yes.
And we thank you, nice people, for that.
Yes, we always have a tremendous amount of listener appreciation, and now it's getting challenging. There's more than one listener.
Yeah. Ooh. It's a lot of people to thank now.
Yeah. But it's good to hear that, the reviews weren't these guys suck and it's a total waste of time and don't bother.
Right,
so,
right.
Just want to say we appreciate it because, as you've gathered, a lot of this is Mike and I just kind of catching up and talking to each other, and the listener gets to go along for the ride, but we try to be accommodating. So if you have kind words or other words, you're more than welcome to share them, but we appreciate the kind ones.
Yes, indeed.
Yeah. All right, well, time flies by. We should probably unveil these trivia question answers.
Yes. Okay. All right, Kevin, I asked you, when and where was the first drive-in opened?
Yes, right. And I believe I said it was in 1927 in Kansas City, and I know that's...
Correct.
No.
Kansas City, Kansas, no less.
Right. Correct as in that's what I said, not correct
yes.
that I'm right.
Correct as that is what you said.
Because I almost, wet my pants there for a second.
What a guess! But unfortunately, the answer is 1933 in Camden, New Jersey.
There you go. See, now it all comes back to me.
Right, yeah. Whenever you tell me my wrong answer, it all comes back to me as well.
But like
Not
I
unlike
said,
this one.
Yeah, but I did look this up before, so it does come back. Yeah.
I debated on whether I was going to ask this. I'm thinking, there's no way he's not going to know this.
Yeah. See, that tells you the broad spectrum of my ignorance is confounding. Because there's a lot.
It's confusional.
It's right. A lot I don't know. All right. Well, my question to you was, why was the 426 Hemi Chrysler V8 426 cubic inches? Mm-hmm. And your answer was something to do with an NHRA rule making that engine legal for racing based on a 427 cubic inch displacement limit. Mm-hmm. And I will say that you are incorrect.
Oh!
Because the correct answer is that there was a 427 cubic inch displacement limit established by NHRA, AHRA, and NASCAR.
Oh, man!
So you are correct.
Boom! Look at me.
How about
winner?
I am really, I wasn't expecting that you'd get that one so readily.
Oh, man. I felt really good about this one, I gotta say.
Yeah. Well, and the funny thing was I did not prepare properly for the show because,
really?
As you know, I was too busy eating a pizza right before our start time, which kept getting pushed back because I was waiting for the damn pizza guy. That's only funny because it's true. So as I'm getting ready to do this, I'm thinking, oh man, I got to do a trivia question here. So I grabbed it's a little magazine, a little, on little pages, from 1963, and it's called How to Hop Up Your Engine.
Oh, nice.
And when you open the first page, it's got a story about the recent 427 cubic inch displacement limit established by NHRA, AHRA, and NASCAR is affecting Detroit noticeably already. And they talk about the new 426 Hemi. And I went, I bet Mike doesn't know that. And sure as heck, you got it.
Yes.
So,
yes.
Well played.
I'm like 2-50. Yeah.
Well, I mean, it's not like this was a recent thing on Facebook or whatever.
Right.
I mean, this is printed in '63. Last copy here in my garage. So. Impressive. Congratulations on that.
Thank you very much. Appreciate that. Bang bang.
Bang bang.
Bang bang.
All right. Well, listen. If I need to get a couple of. I'm going to ask this. Do you still have your welding sample?
I do. Yes, I do.
Is it on the fridge?
It is, as a matter of fact.
Send me a couple snapshots of that, and we'll try
Okay.
and put pictures up in the story article for this broadcast.
I sent you some snapshots.
You did, correct, and videos. I got to check that out too.
Yeah.
Maybe I can get some for that. Yes, you did send me snapshots, and you even wrote on there first weld.
First weld.
Yeah.
What, March 24th,
There you go.
2018, VATV.
I will share those as well, and you'll be able to see that on the V8 TV or the V8 Radio website article. Unfortunately, if you're listening on iTunes, we put images on the website that iTunes doesn't pick up, so they don't get a chance to see those.
I got you.
Or with Google Play or Stitcher or
Tune
the
in.
iTunes, the TuneIn Radio deal, or on the Facebook page. But you're more than welcome to listen to all those. And I've noticed that we're kind of springing up and down a little bit in the popularity
Oh boy.
on iTunes. We were about
Can't fall off.
no, we haven't fallen off. We were about 18 from the last, and then we went up to about 25 from the end, and I think whenever an episode hits, we'll rocket ahead,
I see.
and then
I see.
other ones come out, and they'll push us down. So we appreciate
gotta-
everybody listening. That we're still gunning for Car Talk. And,
Car Talk.
and Adam
Coming
Carolla.
to get you Corolla.
Yeah, we'll get them. But we invite you to subscribe and listen at any of those outlets, and we appreciate you spending the time. So that's about all I got, my friend.
Likewise.
All right, well, listen, it's been fun as always, and keep it under 100. And we will talk at you next time on V8 Radio.